Welcome to Inside the Lab with Aero Electronics, the web series dedicated to exploring the latest in technology and electronics. In this episode, we'll show you the Analog Devices CN0363 dual-channel colorimeter, with particular emphasis on some of the ADI components that drive it. A colorimeter is used to measure light absorption by a solution to determine the concentration of a solute. The CN0363 is not a typical evaluation board, so let's jump right into a demo to show you how it works. The board is full of components from ADI, but we'll focus on the op-amps and ADC that are at the core of this colorimeter. This colorimeter uses an FPGA to perform digital synchronous demodulation, which provides a number of advantages over the analog equivalent. One is that the analog demodulation hardware is removed, lowering the noise floor. Second, the light source is modulated using a sine wave rather than a square wave, eliminating the harmonic noise of the square wave. This leaves us with phase mismatch and drift as the two big remaining challenges. Phase mismatch can be addressed much easier in the FPGA than in hardware with things like variable capacitors. Drift is addressed through calibration, but by using the right hardware, you're able to reduce the calibration effort. Back to the light sources, the modulated light travels through a beam splitter seen right here, sending half of the light through the sample solution and the other through a known reference solution. Photodiodes are used to detect the light level, and the output current is converted to a voltage by a transimpedance amplifier. A transimpedance amplifier is an op-amp configuration that converts current into a voltage and is one part of the design where drift is a concern. ADI used the ADA4528 because it's a zero-drift rail-to-rail amplifier with a maximum offset voltage of 2.5 microvolts, no 1/F noise, and a very low broadband noise. So not only does it eliminate drift at this point, but it also keeps the noise floor very low for greater sensitivity. The output of the ADA4528 is connected to the input of the ADC, another possible source of drift. For the CN0363, ADI uses the 8071-75-2, a 24-bit, 250 kilosamples per second sigma delta ADC with an integrated 2.5 volt low drift reference. This is the only source of drift, and it is well specified, making it easier to account for in calibration. This combination of software with the right hardware reduces BOM cost, design time, and calibration frequency and complexity. So the sampled data is passed via the SPI interface to the FPGA, where the demodulation is applied to measure the light absorbed by the sample solution compared to the reference, and displays the results here on the screen. The sample data is passed via the SPI interface to the FPGA, where the demodulation is applied to measure the light absorbed by the sample solution compared to the reference, and displays the result here on the screen. So right here in the reference solution, we have distilled water, and then over here we have a red syrup. So as I analyze the sample, it will warm up the three LEDs in line, first doing the red LED, and then it'll also warm up the green and the blue, and it'll take samples after it's done warming up each LED. And after it's taken those samples, it'll display it up here. With the red, I'm expecting green and blue. So green, we've got 1.2905, and blue, we've got 1.529. So we can take this out and transfer a red sample, switch it out for a blue sample, and run it again. And again, what it's doing is it is lighting up these lights, putting it through a beam splitter, running the light through distilled water and also through the sample, and then comparing the absorbance with these two sensors over here. And we'll see on here that we should get some red absorbance. Yep, so we get 0.6772. Analog Devices 807175 ADCs and ADA4528 amplifiers provide the performance and capabilities necessary for demanding applications like this dual-channel colorimeter. And they also lead to a lower cost, simpler design with improved dynamic range and sensitivity. For more information, visit aero.com.